Imagine floating 400 kilometers above Earth, and suddenly you hear it, a faint hiss. Not loud, not explosive, just a thin, steady whisper of air escaping your spacesuit. What happens next will shock most people, because Hollywood got it completely wrong. In the movies, your body explodes instantly. Your blood boils. You freeze solid in seconds. None of that is true. Here's what would really happen, based on NASA data, documented vacuum exposure tests, and actual astronaut training protocols. First, understand this. A modern NASA spacesuit operates at about 4.3 pounds per square inch of pure oxygen. That's far lower than Earth's sea level pressure of 14.7 psi, which is why astronauts pre-breathe pure oxygen before spacewalks, to purge nitrogen and prevent decompression sickness. Now picture a tear forming in that suit. If it's tiny, like a micrometeoroid pinhole, you might not even feel it at first. Spacesuits are built with multiple pressure layers, thermal insulation, micrometeoroid protection, and real-time monitoring systems. The suit constantly tracks internal pressure. If it drops, alarms trigger immediately. You would have seconds to respond. And here's the first pattern interrupt. You do not instantly explode. The human skin is strong and elastic. It can withstand internal pressure differences far better than movies suggest. NASA vacuum chamber experiments and documented accidental exposures show the body does not rupture. But something else happens, and it's far more terrifying. At extremely low pressure, bodily fluids begin to boil at normal body temperature. This process is called ebullition. It doesn't mean you boil away like a kettle, but water in your saliva, on your tongue, and in your eyes will begin to vaporize. Your skin would swell, not burst, swell. Studies show the body can expand to roughly twice its normal volume if completely depressurized, but the skin holds. Think of it like severe full-body bloating. Now here's where it gets critical. You would lose consciousness in about 10 to 15 seconds. Why? Because oxygen is no longer being delivered to your brain. If you try to hold your breath, it gets worse. The expanding air in your lungs could rupture lung tissue, causing barotrauma. That's why astronauts are trained. Never hold your breath during rapid decompression. Exhale immediately. There was a real incident in 1966 during a NASA vacuum chamber test. A technician's suit hose disconnected in near-vacuum conditions. He later reported that the last thing he felt before losing consciousness was the saliva on his tongue starting to bubble. He passed out in about 12 seconds. The chamber was repressurized within 25 seconds. He survived, with no permanent injury. That's not science fiction. That's documented. So how long could you survive? If repressurization happens within roughly 60 to 90 seconds, survival is possible. Beyond about 2 minutes, irreversible brain damage becomes highly likely due to oxygen deprivation. Now here's another mythbuster. You would not instantly freeze. Space is cold, yes, but space is also a vacuum. Heat transfer in a vacuum happens mainly through radiation, which is slow. You would actually lose consciousness from lack of oxygen long before freezing became an issue. And you wouldn't instantly explode from internal pressure. But what about blood boiling? This is where precision matters. Your blood is inside a pressurized circulatory system. As long as the cardiovascular system remains intact, blood doesn't boil away. However, exposed fluids, like moisture in the lungs, can vaporize. If the tear is small, the outcome changes dramatically. A small puncture does not mean instant death. Spacesuits are compartmentalized and reinforced. NASA's extravehicular mobility unit includes multiple fabric layers, including Kevlar-like materials and Dacron restraint layers to maintain pressure shape. A minor leak could allow time, possibly several minutes, to return to the airlock, depending on severity. Astronauts also work in pairs. There is always a partner. And here's the controversial part most people don't realize. Micrometeoroid impacts are rare, but not negligible. The ISS is hit by tiny debris frequently, but spacesuits are engineered with shielding to withstand particles traveling up to several kilometers per second, depending on size. A catastrophic tear large enough to cause explosive decompression? Extremely unlikely, but not impossible. If a large rupture occurred, decompression would be rapid. You would experience violent airflow exiting the suit. Vision may blur due to hypoxia. Within seconds, unconsciousness. But again, not explosion. Not instant freezing. Not dramatic Hollywood chaos. Instead, silent, invisible physics. And here's something even more unsettling. At around 63,000 feet above Earth, known as the Armstrong limit, water boils at normal human body temperature due to low atmospheric pressure. That's why pilots above that altitude must wear pressure suits. Space is far beyond that limit. So if your helmet visor cracked completely, your saliva would bubble. Your eyes would not pop out. That's another myth. But exposed moisture would vaporize. Your skin would swell. You would black out in under 15 seconds. And if rescued quickly enough, you could survive. Now think about this. Every time astronauts perform a spacewalk, sometimes lasting 6 to 8 hours, they are protected by nothing more than fabric layers, pressure systems, and engineering precision separating them from instant unconsciousness. Yet in over 60 years of human spaceflight, no astronaut has died from vacuum exposure during a spacewalk. That's not luck. That's design, redundancy, and relentless safety protocols. Before every EVA, astronauts spend hours pre-breathing oxygen. Suit integrity checks are exhaustive. The ISS maintains an internal pressure of about 14.7 psi, similar to Earth's atmosphere, though sometimes slightly lower depending on configuration. There are emergency repressurization procedures. There are tether systems. There are backup oxygen supplies. There are safer jetpacks for maneuvering if untethered. Space agencies do not gamble with vacuum. But here's the reality that makes this both terrifying and awe-inspiring. Strip away the suit, and the human body is not built for space at all. No pressure, no oxygen. Extreme temperature swings from minus 150 degrees Celsius in shadow to over 120 degrees Celsius in sunlight. Radiation exposure. Space is not just hostile. It is immediately unforgiving. And yet, with engineering, we survive there. That contrast is what makes a torn spacesuit such a powerful thought experiment. It's not about dramatic explosions. It's about how thin the line is between life and unconsciousness. Roughly 4.3 psi of pressure, a few millimeters of composite fabric, layers of restraint stitching, and about 10 seconds of usable consciousness if it fails. That's it. So next time you see a movie where someone bursts like a balloon in vacuum, you'll know the truth is quieter, more clinical, and in some ways, more disturbing. You wouldn't explode. You would swell. You would black out. And if help didn't come within about a minute, that would be the end. Space doesn't need drama to be deadly. It just needs physics. If this changed how you see space survival, follow for more science explained without the Hollywood myths. Now I want to ask you, if you had 10 seconds of consciousness after a suit failure, what do you think your first instinct would be? Panic or problem solve?